Alrighty, so like I said, today we're going to be looking at polar, okay, reintroducing polar. Yeah. Polar coordinates, right? So we introduce the idea of a completely different way of locating points in a plane. All right. So since it says here since middle school, I would argue you've probably been doing it since elementary school, right? Using the rectangular coordinates with points x and y, right? And so to locate a point on the xy coordinate system, right? You use the x coordinate to tell you how much to go left or right, right? And then you use the y coordinate to tell you how much to go up or down, right? It's like battleship, or any kind of, just whatever. That's a typical coordinate system, right? Even like longitude, latitude, pretty much is like that too, all right? But the polar coordinate system introduces a different way of locating points in the plane. And so this small adjustment in how we locate points, right, then creates, kind of like a whole different paradigm of how we have to think when it comes to, what we're going to be using it for later and stuff like that. So it's super important we kind of like understand the fundamental idea of how a polar coordinate works so that we can then, apply calculus and stuff to it too. Okay? So, to form a point in the system of polar coordinates, all right, you fix a point O called the pole or origin, right? So that point O, that's like our origin in rectangular coordinates. It's located at 0, 0, right, where the x-axis and y-axis intersect, okay? Here we call this the pole, okay? And so the idea is then an array, there's also a single ray that emanates or comes out from the pole there, and that's called the polar axis, okay? In rectangular coordinates, this would be like the location of the positive part of the x-axis, okay? Then to locate a point P, we're still going to need to use two numbers, right? Because it's a two-dimensional space, so you need two numbers to identify where that single point is. And those two numbers are r and theta, okay? So no longer are we going to go, left or right and then up and down. Instead, we're going to open from the polar axis. We're going to create an angle theta off of that axis, okay? If it's a positive theta, we're going to go in the counterclockwise direction. If it's a negative theta, we'll go in the clockwise direction, okay? And then we will extend a radius, okay, r out from the pole, and that will locate our point. So turn and then extend out, all right? And so that's how we're going to identify where our points are located, right? It's kind of like the idea of, if you think about like rectangular coordinates, if I wanted to get to like the back corner of the room, I could go left a certain amount and then, back a certain amount to get to that point. Or I could also start here, turn my body and face the corner, and then go straight towards that point. Polar would be the second option there, where you're turning and then you're walking out towards, that corner there kind of thing. That would be what polar does, okay? But you're always, of course, turning from the pole and then moving out that distance r. Okay? So that's the main idea there about polar coordinates, all right? So we're going to take some time here and just graph some. Hello, Sean. Good morning. Welcome. All right. So, thank you, sir. Okay. So we're going to take some time this morning just to kind of graph and like graph points first, and then we'll worry about graphing like equations and also worry about converting from like rectangular to polar as well, okay? So it's important to understand here, right, that these are all r points that are r comma theta here, okay? When we read these, oops, I'm off the screen. Okay? And actually, when it comes to graphing polar coordinates, we're going to kind of graph in like the reverse way of what we did when we do rectangular coordinates. So typically with rectangular, we graph the first number and then we use the second number to help us locate the point. Well, in this case, we're actually going to start with our second number here. We're going to find our theta, and then we're going to go out that r units. So I would say 1, rotate, theta from the polar axis. Okay, and then 2, move out r from the pole. R units, we'll say, from the pole. Okay, so actually we're going to start with our second number here, identify the angle, and then move r units away from the pole. All right, so let's also label some things here so we can just kind of, again, orient ourselves a little bit here. This polar axis right here, that's going to have an angle of 0, right? this right here on our plane, what's this angle going to be identified as right here? Pi over 2, right? Yeah, it's the same thing as like our unit circle. This angle will be what? From around to here, yeah, it'll be pi. Okay? And then 3 pi over 2. Okay? Let me zoom out just a little bit there so you can see better. Okay? Very good. And then, of course, within our first quadrant here, we have this angle, and that will be pi over 6, and then pi over 4, and then pi over 3, right? And I won't do all the quadrants there. You get the idea from that point. Okay? We can also, of course, adjust the scale of things here. So, for example, I could say, okay, this inner ring right here, this first one, I could say, okay, that could be radius 1. I'm actually going to say that's radius of a half, though. And so then I'm going to say this is a radius 1 right there, and then 1 half, 1 1/2, and there will be 2 here, 2 1/2, 3, 3 1/2, and then all the way out here will be 4. Okay? So it's going to be every other ring we're going to count by there, just for our sake. Because if you look here, all the radiuses are at most 4. Okay? But it's really, that's a choice you can make, though, as far as like, you know, what scale you want to make your R's. Okay? You don't really have too much choice with the thetas. Okay? But with your R's, you can kind of scale those a little bit there. All right, so let's identify a point, right? So pi over 3, 2 comma pi over 3. So we're going to, again, imagine rotating, turning from the polar axis pi over 3. And so it's going to be somewhere along this R, but we want to go out 2 units. So from the pole, we're going to go out half, 1, 1 1/2, 2, and there's our point. Okay, so there's A, right there. 2 comma pi over 3. Okay, letter B here, 5 pi over 6. All right, so again, from our polar axis, we're going to rotate 5 pi over 6. 5 pi over 6 is going to be all the way over here in the second quadrant, along this ray right here. Okay, and it's going to go 4 units in that direction, positive 4, so 4 units in that direction. So again, half, 1, 1 1/2, 2, 2 1/2, 3, 3 1/2, 4, all the way to the end there. And there's where letter B will be. Okay. So letter C, 0.5 comma 3 pi over 2. So we'll rotate from the polar axis, rotate around 3 pi over 2 to here. Okay, it's along this ray, and we're going to go 0.5 towards. So that's that inner ring right there, and there's letter C. Okay. Let's see here. 1 comma 3 pi over 4. So 3 pi over 4 we know is in the second quadrant, and it's going to be this ray right here. We're going to go 1 out from that, so 1 half, 1. And there's point D. All right. Let's see here. Point E has coordinates 1.5 comma 0. So we are not going to. We're on 0, right? We don't open up at all. We don't we don't have to turn at all here. It's just an angle of 0. And we go out 1.5 towards that 0. So there's 1 and 1.5. And so there is point E. Okay. All right. Point F, we're going to rotate 4 pi over 3. So 4 pi over 3 is in the third quadrant here, right here along this ray. There's 4 pi over 3. Okay. We want to go 0 towards that. So where will we end up there? Bless you. At the origin, at the pole. Yep, at the origin, at the pole. Either way is fine to say that. And so there's F. Okay, so that coordinate F, right? This is part of the interesting thing about polar coordinates, right? In rectangular coordinates, what is the location of this point? The origin. So what are the coordinates? 0, 0, right? Are there any other sets of coordinates that will give us this location in rectangular coordinates? No, there's only one point, 0, 0, in rectangular coordinates. In polar coordinates, is the same true? Is there only one coordinate that will get us here at the pole? No, there's actually an infinite number of coordinates that would locate this, right? Any coordinate that contains 0 for R, any coordinate contains 0 for R, so you can have any other angle you want, right? Any second coordinate there, any theta that you want, as long as R is 0, you're here. Okay, so that's a bit of a unique situation, and as a result of having that unique situation, the fact that a single point in polar can have multiple representations results in different kinds of graphs. Whereas in the rectangular coordinate system, right, it's, I guess you could say it's like kind of like one-to-one, so to speak, right? Every point has a single coordinate associated with it. You can't have, multiple coordinates associated with the same point. So, anyway. All right, so let's continue here where we left off. F. So G. Okay, now G introduces an interesting idea here. What's different about G? We have a negative r. So we're still going to follow our same procedure here, right? We know we can go the pi over 6. But how do we represent going -2? We know a +2 goes towards the pi over 6. So exactly, we're going to go in the exact opposite direction. So instead of going towards pi over 6, we're going to end up actually going towards what angle? 7 pi over 6, this way. Exactly right. So we'll go 2 that way. So there's 1/2 1, 1.5 2. Okay. G. Okay. So here's something even crazier, right? The fact that G has coordinates -2 pi over 6, but we could just as easily say G has coordinates +2, 7 pi over 6. Right? But of course, there's even more ways to represent this location that G is identifying, right? It's this point. It could be this point. But of course, we can also use the idea of co-terminal angles, right? I could add 2 pi to pi over 6, and I'd still end up in the same location, right? Or I could add 2 pi to 7 pi over 6 in this point, and I can still end up in the same location. So every point, every coordinate in the polar system has an infinite number of ways to describe it. All right. Whereas again, in the rectangular system, every point only has one way to describe it. One unique set of coordinates. Okay. Anyway, moving on here. -pi over 3. Okay, how do we handle -pi over 3? We know +pi over 3. We're going to go towards this direction, right? Go counterclockwise. So what should a -pi over 3? What should we do? Clockwise, yeah, clockwise pi over 3. So clockwise pi over 3 to this ray right here, and we'll go 3 towards it, because it's +3. So there's 1/2 1, 1.5 2, 2.5 3 right there. Okay, and so there's H. And then finally I, okay, 11 pi over 6, so it's a +11 pi over 6. We'll go, whoa, all the way around here to there. Okay, 11 pi over 6 is this ray. We're going to go -4, so we'll go 4 in the opposite direction, which is back out to, oh, it's the same as point B. Okay. So there it is. All right. Questions on any of that? All good? Okay. So let's turn the page here. So rectangular and polar coordinates, right, are both used to locate points in the plane. So you would hope that there is some way to kind of like translate between the two, right? Some way to kind of translate between the two. And so let's examine how we might do that, right? I'm going to redraw, actually I'm going to draw kind of like our, XY axis here. Okay, so I'll say that's X, that's Y, right? But then that's just also, of course, our polar axis as well. Okay, and then of course here's the origin / pole. Okay. And again, let's remember here, if we're going to identify a polar coordinate, right, we're going to rotate some angle theta, and they're going to extend from the pole some distance r, and locate this point here, r comma theta. Okay, so rotate and then extend there r comma theta, right? That's the idea for polar. But with our x and y axis on here, we can also identify that, well, this point, the same point, will have a distance x, a horizontal distance x from the pole, and it will have a vertical distance, bless you, y, off of the x-axis there. Okay. Well, what kind of relationship do we have here? We have a right triangle. We have hypotenuses and stuff like that. Right. Okay, this is a right triangle. Exactly right. Okay, right? The y is going to be perpendicular to the x-axis there, or the x will be perpendicular to the y, and so we create this right triangle. And so one way we can relate our concepts of rectangular coordinates to our concepts of polar coordinates, we know that x squared plus y squared has to equal r squared. What about theta, though? How can we relate theta? What do we normally use to relate angles and sides of a right triangle? What kind of things do we use? Right, sine, cosine, tangent, right? Trig ratios. Well, we can do that here, exactly. So, like, for example, cosine of theta will equal what ratio? Well, let's see here. So, toa, C-A-H, right? Cosine is adjacent. What's the adjacent leg in this right triangle? X over the hypotenuse, r. Or, to put it a different way, x equals r times cosine of theta. Right? Just multiply both sides by r. And so, aha, we have a direct conversion. Given a polar coordinate r theta, we can take our r, multiply by cosine of the theta, and you get the matching x coordinate in rectangular coordinates. Okay? Likewise, let's say sine of theta here. Sine of theta would be what over what? Y over r, which again, if we take a quick conversion there, y equals r times sine of theta. Okay. Guys, remember doing the unit circle and how we found the unit circle, right? We did exactly this. We used right triangles. The radius in the unit circle was always what? Well, it's called the unit circle, so the radius was what? 1. So imagine putting 1s in here. Didn't we find the x and y coordinates on the unit circle using cosine of our angle theta, sine of our angle theta there, okay? X is just r times cosine. That was like a kind of like a more basic version of converting polar coordinates, right? On the unit circle, you were using polar coordinates. It's just that your r was 1, and so that kind of you missed that part of it, but you at least had the theta to locate points, right? So we were doing that in the unit circle. Right. This relationship right here is going to be super important for a lot of the work that we're going to be doing, so make sure you have that down. X equals r cosine theta, y equals r sine theta. Think about it alphabetically, right? X comes first, then y, cosine starts with a C, that comes first, then sine, right? They both have the r in front kind of thing. So use that to help you. We're also going to utilize tangent as well sometimes, okay? What is tangent of theta going to equal according to this? Y over x. Okay, so that'll also be helpful here too. Okay, so also want to have that. So these, essentially, these three kind of groupings here that I made, right? These three things are going to use to help us convert from polar to rectangular or rectangular to polar, right? These three relationships. Well, I guess there's really 4 there total, right? Add them, count them individually. Okay, so let's actually then do some conversion, right? So convert the following polar coordinates, into rectangular coordinates. Okay, so we're told here this is r theta. So this is a polar coordinate. We want to convert it into rectangular coordinates, right? So that means we need to come up with an x. We need to come up with y, right? Well, we know x is r cosine theta. Okay, so what is our r? 2, right? And then cosine of pi, right? So there's our x coordinate. Of course, we know cosine pi is -1, and so we end up with -2. Okay, let's do our, so there's our x coordinate, the matching x coordinate, right? Let's do y. Y equals r times the sine of theta. So again, our r is still 2, and then sine of theta is sine of pi. Sine of pi is 0, times 2 is still 0. So we get the point, -2, 0 there in x, y coordinates. Okay? Which makes sense, right? If we go back to our polar, our polar graph there, our polar graph paper, okay, polar graph paper here, right? open, an angle. It's the angle. I'm sorry, the point was 2 comma pi. So we'll rotate pi. There's pi. We go 2 out. So 1/2 1, 1.5 2. There's our point, right? Well, wouldn't that be the coordinate in rectangular -2 0, right? So when you're on the axis, it's pretty easy to convert and stuff like that. It's when you go off the axis that maybe you get sometimes some, like funky numbers and stuff. But on the axis, it's pretty easy. So yeah, it's -2 0 there. All right, you guys go ahead and try letter B. All right, go ahead and convert that. And if you're not very comfortable with your trig and stuff like that, you might want to start drawing some, reference triangles for yourself or something. Okay. Okay. And we'll volunteer an answer here. Aubrey, what'd you get?
3/2 root 3 over 2.
Great. 3/2 root 3 over 2. Okay. So there it is. Here, I'll zoom in some on that there. Questions on any of that? All right. So next, let's take a look at now taking rectangular and turning those into polar coordinates. Okay. So again, and by the way, one thing I'll suggest here, you don't have to write an x and a y above these, and you don't have to write an r and a theta above these, but if you find yourself getting confused or whatever, it might be helpful, at least in the beginning, right, to do that for yourself, just so you can, kind of like, maintain your orientation a little bit, right, and don't get, disoriented, because, this looks a lot like, polar and rectangular coordinates look very similar to one another, but they mean different things, and so it's helpful, to kind of do that. Same idea here. I'm going to put an x and a y above this, understanding we're going left, right, up, and down, right, and we want to convert that into turn and then, extend kind of thing, okay? So, if we try and do this using what we did earlier, like for example, we can say, aha, okay, we know x is equal to r cosine theta. We can write, okay, -1 equals r times cosine of theta. We can also write +1 is going to equal r times the sine of theta. Okay, but what's the problem with these two relationships?
There's 2 unknowns.
2 unknowns, right? All right. And so you can, maybe combine these two things together and then try and eliminate something, from there. All right? But the question is, right, we have 2 variables. We want to try and get it down just to a single variable. Well, remember, we have these other relationships here. For example, we know that x squared plus y squared is equal to r squared, right? By the Pythagorean theorem there. So we can use the fact that x squared plus y squared equals the radius squared there. And say, all right, that's -1 squared plus 1 squared equals r squared. So r equals √2. Okay? But when we square root both sides here in this setting, is it okay for r to be negative? In polar coordinates, can we have a -r? Yeah, we could. So you could put a plus or minus in front there. Okay, you really could say, okay, well, it could be +2, it could be -2. Okay? And so let's just say that r is our positive √2 here. Okay? Let's just say r is a positive √2. We need to figure out what our theta is going to be. Well, now we can go back to our earlier relationships And it doesn't really matter which one you use there because they both contain r, they both contain theta, right? So it's just you pick one. I'll use the cosine one. So I'll say negative 1 equals r root 2 times the cosine of theta. Okay. Well, let's see here. Divide both sides by root 2. I get negative 1 over the square root of 2, which is equal to cosine of theta. Negative 1 over the square root of 2 is the same thing as negative root 2 over 2 when you rationalize it there, right? That might help you to recognize that that's really negative root 2 over 2 if you rationalize. Okay. Cosine of what angles theta give you negative root 2 over 2? So not positive pi over 4, or not, yeah, not pi over 4. Pi over 4 will give you positive root 2 over 2. So yeah, like 3 pi over 4, 5 pi over 4, one of those two. So you can say like 3 pi over 4, 5 pi over 4, you know, etc. Really, there's an infinite number of possible answers there. You could add 2 pi to 3 pi over 4, or add 2 pi to 5 pi over 4, add or subtract those, and you know you get a bunch of answers. So I'll just use the 3 pi over 4 there. Okay. There's a ton of possible answers there. What's the matter? Yeah, no, 5. Oh, sorry, question. Yeah, go ahead.
On the test, would you just like pick one and it's like that, or is there going to be specific?
Right. So I think of course, if it's like a free response like this, you're welcome to pick whichever one you like. On if it's multiple choice though, you want to make sure that of course you're able to match kind of thing. So I would just again think coterminally and stuff like that. Right. Cosine, yeah, it'll be negative both in the second and third quadrants there. Okay, and then we can do the same thing, obviously, for sine. So we'll say negative, not negative 1, sorry, positive 1 now for sine. 1 equals r sine theta. So then root 2 sine of theta. So we have 1 over the root 2 equals sine theta, which is then root 2 over 2. And so then theta equals, and again, for this one, you have many options. We could say pi over 4, okay? We could say 3 pi over 4, something like that. So I'll just, comma again from there. So then I'll say, whoops, I made a mistake here. Did I do a, oh no, okay. So I mean, again, you could say, wait a minute, feel like I messed something up here. No, r is root 2, so we did that. Oh, I really meant to make, okay, well, I was trying to show you could use negative root 2 there. I guess I can just make this, let me just do, well, I'll just leave it the way it is, I guess. That should be okay. Okay.
So you have to pick the 3 pi over 4 since they're the
Right. Hang on a second here, hang on. I feel like I'm making an error here. Cosine. Negative 1 equals that. Positive 1 equals that. Negative root 2, 7 pi over 4. Positive root 2, 3 pi over 4 there. Okay, so right, we want to pick the 3 pi over 4 there because the pi over 4 is not part of our solution set here. So we want to use the 3 pi over 4 angle. Okay, so you do want to check those kind of thing. Okay, so that's what, yeah. Okay, so make sure you use the correct angle that would work for both scenarios there. Okay, again, we have a list of possible angles here, but they need to overlap because this theta has to be the same if we're trying to describe that same point there using the same r coordinate and stuff like that. Okay, so that's the idea there. Okay. Now, another way you can do this. So let's say, Mr. Witt, I don't want to have to worry about like thinking, do my which theta should I choose here, right? Should I choose so for example 5 pi over 4 is in this list, but 5 pi over 4 wouldn't appear in this list, right? But both of them have 3 pi over 4. So what if I don't want to have to worry, Mr. Witt, about which my theta is overlapping and stuff like that? Well, you can go back to this relationship right here. Tangent of theta equals the y over the x. And that allows you then, so if I'll just do it like kind of up in this space here. If you use tangent of theta to help you find your theta in the first place, that'll save you the headache of having to worry about whether your angles overlap or not. Okay? So -1 over 1, because again, tangent of theta is y over x. So I did that backwards. 1 over -1, but it doesn't really matter, because it's still going to be -1. Okay, and then it's a matter of figuring out, okay, when is tangent of theta equal to -1? Well, tangent of theta equals -1 in the second quadrant, right, which would be 3 pi over 4. Okay, and it also equals -1 in the fourth quadrant, which would be 7 pi over 4 there too. Okay, so those are angles you could use too. You could say, okay, then, you know, √2 equals that. Okay, so there's your 3 pi over 4 again. But then there's also the 7 pi over 4.
Would you, if you draw the triangle,
Yeah,
then you have the -1 for the x value?
so draw the triangle here. Sorry, here, draw the triangle. Like a right triangle there. Okay, -1 for the x, gotcha.
And then
+1 for the y. Okay.
Right, because 7 pi over 4 has a -y value.
Okay. Oh, okay. So hang on. I see what you're saying. So -1, as if we're going in that quadrant, maybe like that.
Yeah.
Okay, like that. So we'll go from the left, and they're like that. Okay. And then so you see you have to be in the second quadrant kind of thing is what you're saying. Okay. That makes more sense. Thank you. Yeah. Okay. So sorry about that. I thought I understood it better there. Now I'm looking at my notes. I'm like, we're running into these issues where we have multiple angles that don't work. 7 pi over 4 here would not work.
Well,
So,
wouldn't the
yeah.
7 pi over 4 just be the other one? 'Cause if you were to put, it says 2 sets, so you would have to do one.
Oh, you're
with a
right.
Positive, one with a negative.
You're right. Okay, yes. One would be positive √2, one would be
Yeah,
negative
that's
√2.
awesome.
Yes, yes, yes. Yes, yes, yes. Yes.
For that one.
Okay.
Come on now.
Okay. Yeah. All right, well, I'm sorry about that, guys. I thought,
it's
again,
okay.
I understood it better than I did. This is not good because it's already, well, anyway. All right. We won't dwell on that. So my point is here. So let's review, I guess. Let me should go back here to what I was originally talking about. So we had to, all right. So -1, 1, we want to find r in theta. All right, so let's summarize here, right? You can find your r by going into, the Pythagorean theorem there, and you get plus or minus √2. So there's two different, r's you can use there. All right, this will end up with, okay, I see. And then you can also use tangent of theta then to get your, thetas as well. And so it's a matter of pairing up the right r with the right theta, I guess, kind of thing. Okay, and knowing which one goes with which. Trying to see here how I can describe that. So what I think then, so again, for these possible r values, maybe it's a better idea to just use r equals positive 2, r equals negative √2, 3 pi over 4, 7 pi over 4. All right, well, I'll talk with Mr. Goff about that one, and I'll clear that up tomorrow or Monday, okay? So let's try another one, okay? Put ourselves through this punishment. Let's see here if we can figure this one out better. All right, letter B, okay? Letter B. So 0, again, equals r. I'm going to do it just in the order that I had it written here, and maybe this will make more sense here. All right. 0 equals r cosine theta. 4 equals r sine theta. Okay. Again, using our x and our y coordinates there. All right. And let's take a different path here. Let's instead start with the tangent of theta. Let's find our theta first, maybe our thetas first. So tangent of theta is going to be, again, your y over your x. So that's going to be 4 over 0. Okay, and so we need to know when tangent is going to be undefined. Okay, and so tangent is undefined. Remember, tangent is sine over cosine. So when cosine is 0, so that's like your pi over 2's, your 3 pi over 2's.
Wait, I'm lost.
Okay, question?
When tangent's how'd you get pi over 2 from that?
So tangent is sine over cosine, right? In
Yeah.
like, the ratios or whatever. And so then
Oh,
sine
because
over
4
cosine,
over 0
cosine
is
0
Okay.
at pi over
I
2,
get
right? So yeah, cosine, maybe I'll write that over here for, cosine of 0. Cosine theta, I did have that right, is equals 0, kind of when, for what theta. So that's for the pi over 2 and 3 pi over 2 there. Okay. And so then we have those two angles. So let's do it this way. Let's say, okay, we've got our theta. So I can go ahead and put the pi over 2 in there. And I've also got 3 pi over 2, so we'll use that theta as well. Okay, so again, this is our theta. We're going to find our r now. Okay, we'll do it this way. We'll find the theta first, and then we'll do the r. I think I made a mistake by doing the r first and then finding the thetas. I think that was my error. Okay.
There's going to be two possible equations, or two possible points.
Well, it said here, convert the following rectangular coordinates into 2 sets of polar coordinates. So you want to come up with 2 of them. Okay, so we're going to use those 2 angles there. Okay, and then for the r, you can use either r sine theta or r cosine theta here to find the r. So I'll use the r sine theta. So we'll use we'll say x equals r cosine theta. Well, I guess I changed my mind there because I wrote x there. All right, and then we'll say x equals r cosine theta here as well. And we'll just use that. All right, and so then our x-coordinate is 0 equals our radius that we're trying to find, cosine of pi over 2. And then our x, which is 0, our cosine of 3 pi over 2. Okay? Oh, Mr. Wid. What's cosine of pi over 2, guys? 0 times r. You can't solve for it. Bad choice, Mr. Wid. Let's go to y. Equals r sine theta. Oh my goodness, it's all on tape too, so we get to listen to this as many times as we want. All right, so the y coordinate here is 4. Okay, r times the sine. I don't know. I'm putting in like random parentheses now. 4 equals r times the sine 3 pi over 2. Okay. So yes, question, Maddie. Yes, with a but though. The problem with that is you end up with 2 possible solutions, positive and negative, and so you don't know which one pairs with which going in that direction. But going in this direction, when we know we need sine of pi over 2 is a positive one, so then r is 4 for a pi over 2. And then here, sine of 3 pi over 2 is a negative 1 times r, so r is then negative 4 for that one.
So, I have a question.
Yeah, question.
Couldn't you just put the negative 4 at the pi over 2 because it would just be the same point anyways? Negative 4 comma pi over 2 would not locate the same point. So again, let's go back here. The xy coordinate is 0, 4. Okay, on the polar axis here, 0, 4, rectangular coordinates, right, 0, 4. We're not going to go left or right at all. We're only going to go up 4. So that would be right here. Okay? So I'll put that arrow right there. All right, but going back to this, okay, if you said negative 4 pi over 2, you see what the problem's going to be here? We're going to open up pi over 2. We're going to go negative 4, though. It's going to go in this direction down to here. So that's why it's important to make sure you match the right sign with the right angle. So yes, Gabe, question?
Can you show how you got pi over 2 and 3 pi over 2 again really quick?
Sure, just tangent theta is going to be undefined. Tangent's undefined when your denominator of tangent, which is sine, is equal to 0. Sine is equal to 0. Sorry, when cosine equals 0. Sine over cosine. Cosine is equal to 0 at pi over 2 and 3 pi over 2. Oh my gosh. All right, so sorry about that. So what I should have done here in the same vein here, okay, find theta
first, 2, then find r using theta, okay, and ignore, don't ignore that, but I mean, that's just, I made it way harder than I needed to there, okay? Find your theta first, then find r using theta, okay? Find r using theta, all right, which is went way better here. All right, now let's just graph some stuff. I promise this will go a lot better. I promise this will go a lot better. Okay, promise. I'm going to take a seat now. All right, so graph the following polar equations. All right, r equals 2. Now remember that we have these coordinates r comma theta here.
It's okay, Mr. Webb.
Oh, it's like bringing me back to like my first year teacher days. It's a first year teacher kind of stuff. So, all right. Okay, so we're going to pick some values for theta, just like you would when you were graphing things back in elementary school or middle school, right? You kind of picked some values, and then you plugged them in, okay? But you'll notice I'm putting the table in like a weird order. I'm putting the theta in first, and then we're going to find the matching r values for it. Even though the coordinates are r comma theta, right? And so if we were following like our normal pattern of things, we normally would pick r values, and then plug those in to get theta, right? Like if it's like the x and the y. But for polar, we typically pick our thetas, plug those in, and get the matching r values. For a similar to reason here, why we solve for theta first and then get our r values. It's just, I don't know. Anyway, so we'll just do it here. Pi over 6, I'm just going to pick some random values here. Pi over 2, not random, but things that we can identify easily on the unit circle. Or not our unit circle, but just on the polar coordinate plane. All right, so if theta is 0, what do we know r is going to be? 2. If theta is pi over 6, what will r be? 2. 2. Okay? So all the r's are 2, doesn't matter what theta is. What does that result in? Right, a circle. Okay? So if theta is 0, we're going to go out to 2. When theta is pi over 6, which is this first one right here, we're going to go out to 2. Pi over 2 goes out to 2. Pi goes out to 2. 3 pi over 2 goes out to 2. Okay? 2 and 2 towards the 3 pi over 2, I should say. All right? And so, yeah, exactly right. We've created a circle centered at the pole. Okay? So, I'm going to attempt one more conversion here from polar to rectangular. So we have the equation in polar is r equals 2. We have the rectangular relationship, x squared, here we go again, right? X squared plus y squared equals r squared. But what is r? It is 2. So x squared plus y squared equals 4. It's the equation of a circle and rectangular coordinates centered at the origin with radius of 2. All right? That one I didn't mess up. Hooray! Moving on. So any question on that? That's pretty straightforward, right? Letter B. Now let's see what happens when we have theta equal a constant number. All right? So in this case, we'll say theta, right? Well, our thetas are all going to be pi over 3, so I'm not going to like bother. You get the idea there. And let's just say r is 1, 2, 3, 4, -2, -3. Okay, all those things right there. So all those r values have theta values of pi over 3. All right, so we'll do, 1 pi over 3. So let's see, here's pi over 3 is right here. 1 out from that's right there. And then 2 towards the pi over 3, 3, 4, so on and so forth, 5. But we also have the -2 and -3 as well. Those negative r values also result in a pi over 3. So pi over 3, but negative means we're going this direction away from pi over 3 in the exact opposite direction. And so what do we create? A line. Okay. Yes, so a line exists in lines exist in polar graphing. All right. A way to represent this is to, question, Sean, or are you just stretching? Okay. So a way to represent this is to use the tangent relationship here. Tangent theta equals y over x. All right, so then tangent of pi over 3 will equal y over x. Because again, the theta will always be pi over 3, so we just replace that theta with the pi over 3 there. But what is tangent of pi over 3? Ooh, this one's a little bit harder to remember, right? Tangent, Mr. Witt, tangents. Well, I'll help you out there. It's root 3. Okay. Equals y over x. Or in other words, by multiply the x over, we have y equals root 3 times x. So what is the slope of this line in rectangular coordinates? Root 3. Exactly right. Okay, so it's a line that's got a y-intercept at the origin and slope of root 3. Okay, but there's the equation in polar coordinates stuff. All right, let's try another one. Continue the fun. All right, 2 cosecant of theta equals... Ooh, now we have a relationship here that includes both r and theta in it. All right, so again, we'll make a little table. All right, 0, pi over 6, pi over 4, pi over 3, pi over 2. So let's just get that first quadrant kind of like figured out, and then hopefully we'll be able to figure it out from there. Okay, so let's imagine taking that theta value of 0 and taking cosecant of 0. Cosecant. Ugh, I don't really like that. Cosecant is the same as what? 1 over sine. So let's go ahead and make this 2 times 1 over the sine of theta. Makes it a little bit easier, right? Okay. So this is, in other words, r equals 2 over the sine of 0. Okay. What's the sine of 0? 0, and then 2 over 0? Undefined, right? And what value, what is that, what does undefined approach? Infinity, right? Okay, it's undefined, but that means it's just going to approach a positive infinity. Okay. So for theta equals 0, we kind of are going to approach infinity. So like a 0 angle, we're going to go like out towards infinity here. So like that's kind of weird, but okay, we'll just kind of go with, I'm not going to bother trying to plot that because it's infinite. But let's try pi over 6. Maybe this will be a little bit easier. 2 over the sine of pi over 6. Okay, well, what's the sine of pi over 6? And 2 divided by 1/2 is 4, right? That's not as bad. So pi over 6, 4. All right, well, that's easy to plot. There's pi over 6, and then going out 4 from that. Ugh, this made this a little bit tricky. So 1, 2, 3, 4, right there. Okay, be careful. We kind of like superimposed like we superimposed like rectangular coordinates on top of the polar coordinates there. So make sure you're actually going 4 units out, right? 4 circles out. 1, 2, 3, 4 circles out there. Okay, let's do pi over 4. R equals 2 over sine pi over 4. Sine of pi over 4 is root 2 over 2, so it's 2 over root 2 over 2, which is the same thing as 4 over root 2, which is the same thing as 2 root 2 when you rationalize. Okay, and then 2 root 2, let me get that as a decimal here, that'll be helpful, I think. About 2.8, okay? So pi over 4 and about 2.8. So there's 1, 2 circles, and then not quite to the third circle, so we'll say, yeah, right about there. Okay. And then let's do pi over 3. Okay. And then sine of pi over 3 is root 3 over 2, so it's 2 over the square root of 3 over 2, which is 4 over the square root of 3, because again you divide, instead of dividing by the fraction, you multiply by the reciprocal. And so we end up with then 4 root 3 over 3, which not very helpful, but as a decimal is about 2.3. So again, for pi over 3, we'll go out 1, 2, and a little bit. Something like right there, I'll say. And then for the last one, pi over 2, r equals 2 over the sine of pi over 2. Okay. Sine pi over 2, it's 1. 2 over 1 is just 2. That makes it easy. So pi over 2, there's our angle pi over 2 right here, and we'll go 2 in that direction. 1, 2. All right, now if we connect those dots, what does that look like?
A line.
Yeah, it's a horizontal line.
Yeah.
Okay. Everything's coming up Widmeyer now. Here we go. All right. As Miss G would say, you can call me butter. I'm on a roll now. Here we go.
Oh my god.
All right. Yeah, commence the eye rolling, right? All right, so anyway, y equals r sine theta. Watch this. Here we're going to do some mathemagic here. All right. Well, r is always 2 cosecant theta. So that's 2 times 1 over the sine theta for your r. But then there's a sine theta there because it's y equals r sine theta. The sine thetas cancel, and y equals 2 in rectangular coordinates. So there it is in rectangular coordinates, the line y equals 2 is the same thing in polar, r equals 2 cosecant theta. Okay? Yep, sorry. I'm moving rather quickly here now.
Okay, thank you.
You're welcome.
Okay, Potter.
Straight out of Africa.
Limacol.
Yeah, I think it's like Lima's. Well, no. This is this letter. And you guys taking foreign languages? Does that show up in one of your foreign languages? There?
Start Latin.
I don't think it's a Latin thing.
Sounds
I
good.
feel like. Well, I don't know what it shows. I forget what. I think it's like Lima San or Lima Con or I don't know. But anyway, yeah, I'm not sure. Anywho, so we're gonna graph this thing here. All right. So we're gonna do again a theta and a table here. Theta in our table. Put our r there. So again, we're gonna do things in reverse order from the actual coordinate, right? A polar coordinate is r comma theta. We're gonna pick our theta though. We're gonna treat theta like the independent variable. We pick it, and then r is gonna depend on that theta. Okay. R will depend on that theta. And this is again the issue that we ran into before when we were the issue that I ran into before, where we were trying to convert from rectangular to polar. With that, you want to just find that theta first, or use your theta first and stuff like that, and then find your r. Okay. Anywho, so we'll start with some like the first quadrant stuff. So 0. I'm only going to do pi over 6. Okay. Now, why am I going to avoid pi over 4 and pi over 3? Well, because I'm using sine, right? And sine of pi over 6 is easy. It's 1/2 to do the math, right? But sine of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. You just kind of like having to figure out those decimals. If you don't have a calculator, you're kind of stuck. So we're going to stick with numbers that are nice and easy to evaluate. Same thing, we'll do pi over 2. We'll then do 5 pi over 6 for the same reason we used pi over 6. Okay. We'll go to pi. We'll do 7 pi over 6. We'll do 3 pi over 2. We'll do 11 pi over 6. And then we'll go back to 2 pi. Okay.
By the way, it's an S sounding.
Oh, it is? Okay. Lima song?
Yeah, it's French.
I thought it was French. I thought it was. So you take French, Mike?
No, I just looked it up.
Oh, okay.
But apparently, in English, if you say limacol,
Oh,
because
and,
you're not supposed to have that when in English. Like,
oh, it's like, okay, I see what you're saying. So Lima Con. Okay, interesting. Thank you, Michael.
Smarty pants.
it actually means snail or staircase in French, if you were wondering.
Well, I can. All right, you guys can debate about whether you see a snail in this after we do it here. Okay. So okay, let's plug in 0. Right. So sine of 0, 0 times 4, 0. 2 minus 0 is 2. Okay. Pi over 6. Sine of pi over 6 is 1/2. So 4 times 1/2 is 2. 2 minus 2 is 0. Pi over 2. Sine of pi over 2 is 1. 1 times 4 is 4. 2 minus 4 is -2. 5 pi over 6. Sine of 5 pi over 6. That's in the second quadrant. Sine is still positive there. So it's going to be 1/2. 1/2 times -4 is -2, so that's going to give you 0 again. Pi, sine of pi is 0, times 4 is still 0, 2 minus 0 is 2. Sine of 7 pi over 6, now we're in the second quadrant, so it's going to be -1/2. -4 times -1/2 is +2, so plus the 2 there makes a 4 for our r. 3 pi over 2 is 0, so it'll be 2. 11 pi over 6, again, fourth quadrant, sign's negative, so it'll be another +4 there. And then finally 2 pi will be back to what we had at 0, which was 2. Okay, so keep in mind, again, these are the points 2, 0. These are the points 0, pi over 6. This is the point -2, pi over 2. We have them in reverse order, but that's because it's just easier to make theta be your independent and r be your dependent there. All right, so let's plot some of these points here. So we'll take this a little slowly here, almost snail-like. Okay, we'll go 2 out. Okay, so there's our first point. And then pi over 6, this next one right here, we're at 0. Okay, so connecting these dots, we might be tempted to just draw a straight line from 2 to this 0 right here, right? But let's be a little bit more careful than that. Our thetas are going from 0 to pi over 6. So we're rotating from this pole, from the polar axis here of 0, we are rotating 2 pi over 6. This means we're going through angles here, okay? We also want to use the idea of continuity, though, too, okay? So from 0 to pi over 6, we're hitting all the angles between 0 and pi over 6. That means, since our r value is going from 2 to 0, we need to hit all the r values between 2 and 0 there. Okay, so simultaneously to rotating from 0 to pi over 6, we also have to go from r values of 2 to r values of 0. Okay, if we go straight from 2 to 0, like a straight line right here, yes, we'll hit all the r values between 2 and 0, but we won't hit all of our theta, all of our angles there. All these angles along this straight line, all those angles are as an angle of 0, right? Because they're along the polar axis. So in order to do what we need to do here, both rotating from 0 to pi over 6 and go from 2 to 0, we're going to have to kind of like arc up, but then arc right back down like that. Okay? Because again, we're rotating from 0 to pi over 6, but then those r values have to decrease towards that r value of 0. So from r equals 2 to r equals 0 there. Okay? This is maybe one of the more difficult things to kind of grasp here when it comes to graphing these equations. All right? The fact that we're rotating from 0 to pi over 6, we have to go through this arc, but then simultaneously to that, we have to go from an r value of 2, rotate around to an r value of 0 there. Okay? So then we plot our next point, pi over 2, -2. So pi over 2, but we're going to go -2, so down 1, down 2. Like that. Okay, so now we're going to rotate from pi over 6, which is like this angle right here, we're going to rotate all the way around. Okay, from pi over 6 around to pi over 2. But we got to be careful here. We're going from a 0 r value to a -2. So that means we're going to hit all the negative r values between 0 and -2. So instead of being up here in the first quadrant, negative r values would put us where? Down in the what quadrant? Third. So we're going to rotate around like this. Okay. Again, the same idea. We're rotating around there to get to that value. Okay, and then we're going to kind of help us use some symmetry here too. So the next thing is 5 pi over 6, 0. So again, we're rotating from a -2. We're rotating back to 0 here. So it's going to rotate. Here's 5 pi over 6. But those are, again, going to be negative r values we're covering, right? We're covering from -2 to 0. So instead of being in the 5 pi over 6 in the second quadrant here, we're actually in the fourth quadrant because the negative r values, and again, looking like this. Okay, rotating back around. All right. And then pi 2. So pi, and then 2 towards the direction of pi, right there. Okay, and you hopefully see by symmetry now what we're going to do. We're going to do that same kind of arc over here that we had over here. Okay, and then that was pi 2. So then 7 pi over 6, 4. So there's 7 pi over 6, and 1, 2, 3, 4. I might have curved too quick. And so again, we'll just kind of curve around to that. 3 pi over 2, 2. So here's 3 pi over 2. I'm going to go out 1. Oh, I did mess that up. I apologize. Yeah, sine of 3 pi over 2 is -1 times -4 would be +4 plus 2 is 6. Thank you, guys. Sorry about that. 1, 2, 3, 4, 5, 6 we'll say right there. So we're going to rotate around to this point. Okay, like so. And then 11 pi over 6, 4. So there's 11 pi over 6 and 4 out towards that. And again, you can kind of see the symmetry here. Okay, and then 2 pi 2 back to where we started.
Yeah, I don't see it.
Okay, so I don't know if I see a snail there, but maybe that's like supposed to be like the snail and there's its shell. Maybe that's just supposed to be the snail shell kind of thing. I don't know. Up for debate, but there it is. All right, we won't get to the rows. All right, but we can maybe do that another time or something like that. I don't know, but okay. All right, so just remember, right? Don't do what Mr. Whitmire did on letter A. Do what Mr. Whitmire did here on letter B, right? Find your theta first using tangent, and then use r cosine or r sine to get your R. Okay.
Mike, are you gonna with us?
All right. Homework we posted to Google Classroom.